All right, let's talk about infrastructure as code. Designing or even just tweaking an architecture typically involves the same key steps. Number one, you discuss your ideas with a team, which is brainstorming, whiteboarding, creating mind maps and diagrams. Number two, you settle on a set of changes to be made and hopefully you write them down or capture them somewhere. Number three, you create or update the infrastructure in your lowest environment. And step four, once things look like they're going the way you want them to, you repeat the previous steps in the next higher up environment, and so on. So what's wrong with this picture? You're doing the same things over and over again. So if you're careful and a little bit lucky, you won't miss any steps the first time through. If you survive the tedium of doing it twice without totally screwing it up, the third time is probably where you get comfortable and you forget to create a security group or set Lambda permissions. So if you're a real whiz, you'll create a script that makes this specific set of changes to a given environment. Maybe it even takes some variables so you can use a different machine size in dev versus prod. You write your script, you get it working, you use it, and then you throw it away without any real record of the changes you made. Who cares, right? It's working now. But a few days later, something's going weird in dev, so your manager asks you to roll back the changes you made so the developers can get back to doing their jobs. Only you don't remember every single change you made, and your script doesn't have a reverse option because why would it? Even if you can undo everything you did before, you just spent all that time making changes, and now you've got to spend more time undoing the work you just did. By this point, you're probably pretty reasonably annoyed. So what are we going to do so this never happens again? Enter infrastructure as code. Infrastructure as code, or IAC, is the practice of describing your architecture formally using code of some form. When you describe infrastructure as code, you can keep it in version control so you can track how it's changed over time from beginning to present, and you can roll back with certainty and no rework. You can duplicate your changes over and over again without having to repeat the same tedious set of steps. Just take the time to describe it once and deploy away. Plus, you can start using completely ephemeral environments. Testing a new change or feature? Stand up a new environment with everything completely from scratch, play around with it, and then tear it all down when you're finished. Think of something else you wanted to try? Deploy another one with a click of a button. So how do you actually go from where you are today to using infrastructure as code? Some common IAC tools are Puppet, Chef, AWS CloudFormation, and CloudReach's Scepter. My favorite IAC stack is AWS's CloudFormation wrapped in Scepter. In this scheme, I create a set of JSON CloudFormation templates, each of which describes some part of my architecture, such as persistence or networking. Those templates alone are technically enough to describe repeatable, reliable infrastructure as code. But with complex environments, there can be a lot of stacks to deploy in a certain order. That's where Scepter comes in. It handles deploying the entire environment set of stacks in the correct order, passing dependencies from one stack to the next. An added benefit is that you can use configuration files to specify parameters for your stacks. This allows you to do things like ensure dev uses small, inexpensive instances, while prod gets the big stuff. Really quick, I want to touch on some best practices and risks. The main drawback, if you can really even call it that, is that to a certain extent, you have to go all in. What I mean is, once you describe your architecture formally, and you should, you need to treat those files as the single source of truth. Any changes to your architecture only exist if you make them in those files. If you stick to this principle, you'll always know exactly what your architecture includes. If you stray from it and change things manually, you'll introduce what's called configuration drift. Alright, so what is configuration drift? Configuration drift is the term for the separation that forms between what your templates say your architecture looks like and the way it actually exists in the real world. It occurs when you create your infrastructure using templates and then you make changes to them manually rather than by changing the template and running an update. This can create environments with unexplained behavior that's incredibly difficult to debug. And it can lead to destructive changes the next time you actually do update your environment using the templates. The key to avoiding the biggest risk with infrastructure as code is to hold yourself and your team accountable and actually use infrastructure as code. Always. So this is both a best practice and a mitigation for the biggest risk with using IAC. If something exists in a template, all updates to it must take place in that template. No exceptions. So let's recap real quickly. Infrastructure as code is the practice of defining your architecture formally in some form of code. Usually this looks like a set of templates that describe your architecture along with configuration files for setting parameters. The biggest reasons to use infrastructure as code are to save yourself repeated work and to know exactly what's in a given environment at any given point in time. Your infrastructure will become more reliable, repeatable, and ephemeral by using infrastructure as code. You can stand environments up on a whim, play around in them, and tear them back down to save costs. When you use infrastructure as code, it's important to stick to using infrastructure as code. Once you describe something in a template, all updates to it need to be made in that template. Otherwise, you risk introducing configuration drift. I hope this was helpful. Thanks for watching.